Nice to see all of you after a very long time.
We are also happy to see you.
The same.
After a long time.
How are you doing? All is good? Huh? You're excellent. And I'm almost 10 years old. Oh, Sina. So nice to see all of you. I'm really feeling very happy. Really nice of you. You all came. Very good. For an occasion like this. Really good. You are really doing something beyond your routine. Professionally, you are good. Keep it up. I think it's really. I should have asked you. It's okay. Another somewhere else.
Namaskar. A very good afternoon to all the dignitaries, senior officials and colleagues. We are immensely delighted with great joy and we welcome you all for today's Dr. Sekhar Basu second Endowment Lecture 2020. And indeed our honor and pleasure. Today's occasion, we have amongst us Dr. Member and former AC and Secretary DAE, a distinguished personality in the community. Shri Anurag Kumar, Chairman INS Hyderabad, Dr. Komal Kapoor, Chairman Chief Executive NFC, Shri V. Mahesh Kumar, President of COA. We are also honored by the presence of Shri R.N. Jairaj and Dr. Dinesh Srivastav. Shri P. Sudhakar, former CMD ECIL, S.K. Midhani. Hemant Rao, former Additional Chief Executive NFC. It is a former senior officials from NFC, AMD and ECIL who have immensely contributed to the growth of their respective organizations. We are privileged with the presence of many senior officials from NFC, AMD and ECIL, colleagues, ladies and gentlemen. We extend a warm welcome to you all for today's program. We also welcome our colleagues from ZC and Kota who joined us through VC. Welcome to the INS members who joined us through YouTube Live and Alex platforms. The Hyderabad branch has been actively involved in organizing lectures and seminars for the benefit of all its members. May I now take the privilege of inviting them to the stage. I request Dr. Komal Kapoor, Chairman and CEO NFC, and Shri V. Mahesh Kumar, President of COA, to kindly accompany the dignitaries of the dais. Chief guest of today's function, Dr. Anil Kakodkar and Anurag Kumar, sir. Thank you, sir. I now request Ms. Akshita to present a flower bouquet to today's chief guest, Dr. Anil Kakodkar, sir, member of Chair, Secretary DAE. I request Shri G. Prahlad to present a bouquet to Dr. Komal Kapoor, Chairman and CEO NFC. I request Srimati Vibharani Singh to present a bouquet to Anurag Kumar, sir. I request Deep to present a bouquet to V.V. Mahesh Kumar, sir, Goa. Thank you, friends. Thank you, sir. For seeking the blessings of the Almighty, I know the Rishi from NFC invocation.
Shanvaradam Sri Karana Shanvaradam Sri Vatapi Ganapatim Bhaje Bhutadi Charana Bhuta Bhautika Prapancha Vitaraginam Vishwakaranam Vighnawaranam Vatapi Bhaje Purakumbhasambhava Nivara Prapoojitam Tribhuvanamajagatam Murari Pramukha Jubasitam Mooladhara Kshetra पूजापूरं अरुषविदूरं भूताधारम् अनादिगुरुगुः घोषितबिम्बं हंसध्वनिभूषितहेरम्बं वातापि गणपतिं भजे. Thank you.
Thank you, Rishi. As we begin today's program, I request the dignitaries on the stage to kindly proceed for the lighting of the lamp and offering floral tributes to Dr. Sekhar Basu. And Mukhtawar to give the welcome address.
Chairman and Chief Executive NFC, Anil Kakodkar, Chief Executive Sri Anil Kakodkar, Dr. Dinesh Srivastava, Sri Sudhakar Garu, former CMD, Sri S.K. Jha, Vidani, D.V.S. Hemantarav Garu, former Additional Chief Executive, officials from different through online. Welcome to all of you. We welcome you all to this program, the second endowment lecture of Dr. Sekhar. Pleasure to invite you all to this program. It is a privilege to host the program with the most renowned and reputed speaker, Dr. Anil Kakodkar. Sir, your presence here is a great honor to the organization. The present in the Middle East with the disruption of supply of hydrocarbons, difficulties to the public industry, as well as the inflationary pressures made everyone to look at nuclear energy once again as a reliable source. People see nuclear energy reliable only when difficulties are faced on fronts. Government, however, already has given impetus with the target gigawatt of nuclear energy production capacity by 2047. Also enacted Shanti Bill for private players. Also, India commitment for carbon by 2070. When PFBR achievement. hopes for dependent source for which is also being and acts as a cushion against disruption of other types of fuels and energy sources. Increasing nuclear energy contribution will also save valuable for exchange reserves. The challenges for increasing nuclear energy are the sites for nuclear fuel cycle facilities, maybe co-location of entire fuel cycle can help in reducing the time required for obtaining necessary approval from regulatory bodies. So gearing up for fuel verification, reprocessing and waste management. Strengthening of regulatory bodies and changing the perception of public towards nuclear energy. One of the things power consumption. However, utilizing only whatever energy used help in the growth of the network. Pleasure to welcome this program and special thanks to Dr. Anil Kakodkar for accepting our invitation and for being present here for the second Endowment Lecture of Dr. Sekhar Basu. Thank you.
I request Shri Anurag Kumar, Chairman, to address the gathering.
Good afternoon. Respected Chief Guest Anil Kakodkar and Chairman AEC, Sri Mahesh Kumar, President, fellow members of Indian Nuclear Society, my colleagues from ECIL, NFC, and other DA, my seniors from ECIL, Sudhakar Sahab, and welcome. Honored to welcome each one of you. A very special welcome to our distinguished chief guest, Dr. Anil Kakodkar, a colossus of India's presence today, and the Dr. Sekhar Basu second endowment lecture honors and dedicated his life to inspiring personality combined with a deep sense of most fitting that this lecture series carries forward the right from our heralding our time to celebrate. I look forward to an enriching session, and I am confident that focus will lighten up the path ahead to all young engineers and scientists here. Thank you very much. Jai Hind.
Thank you, sir. Dr. Komal Kapoor, Chairman.
To give us the second talk on endowment talk to INS Hyderabad chapter lecture here today. My good friend Shri Anurag Kumar Sahab, Shri Mahesh, many seniors of mine, Dr. Jha, Hemant Rao, Sudhakar Sahab, members from the DA family, INS members from AMD, INS members from ECIL, NFC, fellow officers of NFC, and all my colleagues. Also joined by online by various DA units across INS members, and also also I am also known that Mr. Basu also is online. It's a pleasure for us to have this second lecture, Endowment Lecture, in the name of Dr. Sekhar Basu. The first lecture was Shri K. in this way, and in light of the present scenario, as you all know, Government of India Shanti political energy forming up of the his background. His talk today is going to be very much enlightening. Also, he is gearing up by putting up a huge series of reactors. Fuel facilities are getting upgraded, getting enhanced. In light of that, the present scenario in the country for nuclear energy is extremely encouraging. His kind advice, his kind guidance to all of us, I feel is very much necessary in this time. So on behalf of INS, on behalf of NUFOA, welcome you all, and I wish today's lecture will be highly enlightening. Thank you very much.
Thank you, sir. It has been our fortune to have been led by a legend like Dr. Sekhar Basu. May I now request Shri P. Sudhakar, former CMD Israel, to present a brief biodata of Dr. Sekhar Basu.
Respected Dr. Kakodkar sir, Chancellor SBNI and former CENFC, Anurag, INS Hyderabad, Shri Mahesh Kumar, and the Officers Association President, Chief Executive of Dr. Dinesh Sasa, Dr. Jayas, Shri Sir, and Director of Finance of ECIL, Shri Chakravarti sir, distinguished scientists from ND, NFC, and ECIL, and for CMD meetings, ladies, namaskar. At the outset, let me express my gratitude to INS Hyderabad chapter for giving me the opportunity to introduce Dr. who has played a lead role in multiple areas of nuclear engineering and a major contributor to establishing India as a leader in nuclear field. In finalizing document for NITI Aayog. Before taking over as Chairman Atomic Energy and Secretary Department of Energy, Dr. Basu was the Director of Bhabha Atomic Center. Earlier, he was the Director of Nuclear Submarine Program and later as the Chief Executive of Nuclear Board. Dr. Basu, born on 20th September 1922 from Baliganj Government School, Kolkata, and graduated engineering from University of Mumbai in 1974. After completion of 1
school program in engineering. He joined reactor division of BRC in 1970. Designing fuel for boiling water reactor, he showed excellent performance. Later, he took up the development of a submarine propulsion plant and built the land-based site at Kalpakam from scratch. He guided the Indian nuclear propulsion project for seagoing and credited for his effort in building the nuclear reactor, India's first nuclear-powered submarine, INS. He was also responsible for design of nuclear recycle plants at Bangalore and Kalpakam. He pursued the design of the integrated nuclear research plant to a higher echelon. As chairman of the board, he was responsible for the development of the Neutrino Observatory. As the principal coordinator, he pursued superconducting computers for the accelerated. He also signed an MOU with the Foundation to establish an advanced gravitational wave detector project. Dr. Basu of nuclear cycle park involving research reactors and reprocessing facilities at Vizag campus of BRC. As Director BRC, Dr. Basu for the expansion of the societal program of DAE in the fields of nutrition, food preservation, he guided the operationalization and production of affordable radioisotopes at the facility in Kolkata. By pursuing the basic research in the field of nuclear science and engineering, work for expansion of engagement and strategic programs. He chaired the International Committee of major modules of International Thermonuclear Experimental Reactor. In 2002, DAE awards in 2006 and 2007. He is also a fellow of Indian National Academy of Engineers and Indian Society for Non-Destructive Testing. Jadavpur University awarded him with D.Litt degree in 2013. He was awarded Padma Shri by the Government of India in 2014. Dr. Sekhar Basu sir passed away on 24th September 2020 at Kolkata, leaving an indelible impression in our memory. His inherent passion for self-reliance in critical technologies will continue to inspire many generations. Thank you and Jai.
Thank you, sir. Though Dr. Anil Kakodkar needs no introduction, but for the benefit of newly joined officers, I request Shri R. Balachandran, Secretary INS, to present his biodata.
Good afternoon, all. It's my great privilege and honor to introduce our guest, Dr. Anil Kakodkar, distinguished and early leaders. earliest leader in India's energy establishment as chairman of Atomic Energy Commission, Secretary Department of Atomic Energy 2000 to 2009. He has played a pivotal role in shaping India's indigenous nuclear program. His contributions span the development of pressurized heavy water reactors, the conceptualization of heavy water reactor with utilization, and the successful revival of critical nuclear power plants. He was also closely associated with India's landmark nuclear tests at Pokhran in 1994 and 1998. Key strategies advancement, including nuclear submarine propulsion program. Under his leadership, India's nuclear program achieved significant growth despite global constraints, strengthening the country's position as a physical and advanced nuclear nation. Beyond nuclear science, Dr. Kakodkar has made remarkable contributions to education and institution. He has been instrumental in establishing institutions such as Homi Bhabha National Institute (HBI), Institute of Science Education and Research (NISER), DAE Mumbai University Center for Basic Sciences, and high-level committees shaping the future of technical and higher education in India. A recipient of India's Padma Shri, Padma Bhushan and Padma Vibhushan, along with numerous national and international awards, Dr. Kakodkar continues to contribute actively across energy, education and societal development. Ladies and gentlemen, read a proud moment whose life's work has significantly contributed to India's strength and self-reliance. Let us warmly welcome Dr. Anil Kakodkar.
Old colleagues, many young people, colleagues from nuclear fuel complex, CIL, AMD, indeed the entire INS fraternity who is present here, and also ladies and gentlemen. First of all, let me express my gratitude to be able to with you through this medium of second Sekhar Basu Endowment Lecture being organized under the auspices of Indian Nuclear Society Hyderabad chapter. And Komal Kapoor suggested that I should speak here. I immediately accepted because I think, as you will all agree, we are all passing through exciting times. The first critique of PABR a few days ago, 6th of April, it has made the entire DAE family very happy. But we sense a deep, strong excitement across the country. So I thought maybe a good occasion to exchange notes more particularly about from here. And so I'm very happy to see of and organizations in Hyderabad to provide opportunity for me. This is Basu. I have worked closely, known him for a long time, almost since he joined BRC. But so it's not for his contributions are very many. But I think it's important to recognize for programs to move forward, you need bold and was once very I'll give two. The first one, in terms of the growth of nuclear, everybody is looking for scale, rapid scale of the country, and of late the change has been recognized, has become even more crucial, and of course you need a lot of the center. Now, politicians usually they take decisions when they know that there is something which is necessary. Their scale or measure perceive as people, and so the growth of nuclear power was in a kind of stalemate when I think it is to the credit of Sekhar Basu, who mooted the idea that to nuclear we must not that reform was not being done, but that was a big decision. We must convince be responsible for implementing it. It is also the construction in India for nuclear program began. We should recognize that. Second, in terms of the project, and need more construction, a lot of push. The launch of PFB had to be given a lot of push. And just what pressing us is plutonium. Constant, you ask what is the status of PFBR, so they will ask what is the status of plutonium. And processing program has been going on for a long time in atomic energy. We had some reprocessing, but that is the time also for somebody who would take these plants and put them to operation at the same level of performance as nuclear power plants. to always that I want also to put nameplate, and I think that really happened after Basu took over the recycle, and to be that at Car Kalpakam while he was still working on PR to get, and I think I'm sure recycle pass every meeting. Processing plants started working to their nameplate, and that was brought about by Dr. I think to be in this endowment lecture in his honor. There is and to sort of work forward from here, and I'm going to share some ideas and let me add a disclaimer. I have retired for a long time ago, so what I'm saying is what I'm saying, but that doesn't necessarily mean that that is the DA program. So you follow the DA program. That we make that distinction. Now, in addition to a couple of facilities see, and clearly in a role in terms of supporting the accounting program, and I'm fortunate enough to have started from scratch when the construction of not that talent observe what's happening here. So I was trying to submit. Dr. Kondalrao used to say, and I'm sure it's a slogan for all of you, I myself after a long I had July components to be made here at it. But the other pressures which NFC would have on the nuclear supplies. So one day I took Balaramurthy, we led both NFC and NFC at that time. Dr. Kodalrao, so him that my reentrant cancer not happening. And so for me, he used this term equals in commitment to the person. So always looked at NFC as somebody in commitment. And I saw the spirit even today, either going through the facilities. So coming to all of you here, I think same thing is true for India and ECI. It goes through a lot of transitions. Some are a captive organizations. None of your publicity. So, stories that go on. But the fact is, that whenever there is a crisis, ECI to act and deliver. And I remember nothing to do with the Commonwealth Games were the huge security issue. And so I think there was this big scare about the security management and ECIL on that technology. I don't know whether you got your money or not. So I think same thing about AMD. Before the negotiations, successful negotiations on CLD, very short of uranium availability for operating reactors. And I know Jairaj, I think, make some fuel bundles. So it was a period. In fact, I think the thing which all of you, all of us should be happy about is the fact that the reactor reconfigured so that it can operate at 70% capacity uranium requirement of uranium. And NPC reactors were red. Crisis NPC loss. The program has come through all challenges which all of you have taken. I thought rather than talking on future. It's 4 o'clock. Okay. So you don't mind being here for another 30 minutes. So my view, what's in store future as far as any standard operating part of course during the construction has picked up momentum. The fleet mode construction which I referred to is and I do hope that we will have another fleet of 10 reactors and more. So whatever we hear, plans made by Nuclear Power Corporation through PHWRs, surely you expect NPCI to deliver a significant part of the 100 gigawatt nuclear mission by 2040. So, and I hope it must happen because one of the apprehensions, in spite of so much of excitement as a result of the PMBR criticality, everywhere in the media reports there will be some last word, one sentence about scale, how we will scale up. So we are yet to fully demonstrate our plans on things on scale. I'm not talking about NFC. You have done that, but the departments as a whole. So at that time, of course, uranium scarcity problem. And I know AMD took up major exploration activity. So 60,000 tons that we were talking about in those times, again very lean ore, very expensive uranium, but that quantity is now I think upward of 4 lakh tons, which is again I don't know how much of it is being actually used in our reactors, but I must domestic uranium must form a significant it's not first of all uranium it's expensive in terms of tariff that impact I think is marginal. Nuclear power is expensive, but that's a fallacy. I related details of the thing, and I can only say that nuclear power is competitive in terms of tariff as any other power, be it coal, be it solar, be it, sometimes we do hear that wind is available at 2 rupees something like that. But fallacy is that cost of say, photovoltaic power as it is used. But you don't use power as it is produced. It has to be conditioned and delivered to homes. And the same power, by the time you go home, people have to invest in the discounts, invest in, call it storage, call it electricity board committed to deliver power with voltage regulation and frequency. Renewable energy as produced is hardly that. And so there is a time the thing 40 paise everybody, that's the cost of thing. And now you have it's now I think the people who are involved in it. By the way, I was also I'm the first chairman of Sekhar, so I know that story also inside out. So the note is it took a little while for to recognize this issue, and then invite R for renewable energy with 6 hours. Immediately those bids from 2 rupees 50 paise to maybe 5 rupees 50 paise, 6 rupees, and that's the time. A little bit of extra tariff element for use of Indian uranium is not going to make nuclear power uncompetitive and imported uranium, but it's not uncompetitive. Even if you leave that, this find, and AMD must do this and find more uranium, but this is a great insurance. The insurance or supposing there is a disruption in supply, there are measures which are built in legally. But keep those legal things aside, the best insurance is you have available on soil. It's extremely important. So I thought we must recognize that and I think we must keep continuing the contribution. Now, in addition to this mainstay for the nuclear power program, of course, you expect some contribution from, say, large imported reactors. Kulam is making that maybe, but don't expect a significant contribution coming from systems. The validation has taken place abroad. Russian reactors are somewhat capital cost compared to PHWs. But if the validation takes place in Western economy, it will become even. And why house reactor has not seen the light of even for construction. People say it is a Security Act, but it's uncompetitive. And so going forward, while one could expect something, but this contribution of light water reactors can happen in a big way only if the value not whether you have HWR or like PWR that we should keep. Even talk of SMRs, which is very common. Everybody talks about SMR. SMR also in a moment, but SMRs built outside are unlikely to be not going to make any significant. Maybe mass manufacture of SMR in India. I think it takes time because unless the order book builds level of 15, 20 reactors simultaneously on order, only then this. So SMR's two conditions: manufacturing in India, order book going to the level of not one or two reactors, but 15, 20 reactors. Then it would work. Now, let us. I'm concerned that behind the bandwagon of SMR, we should really focus on not necessarily failures in the lab. Those are actually technology. We should focus SMRs on the next gen technologies which we need for stage. People are talking about it running on molten salt reactors. Why put that in? Everybody talks about green hydrogen. According to me, any electrolysis, a pressure reactor produce green hydrogen, thermochemical splitting of water. That's the step of energy consumption. It is bound to be cheap. And finally, I would focus on SMR, which is a reactor which produces green hydrogen. And the industry is waiting to buy this. They are all, you know, much of fertilizers green hydrogen. They get dampened down because they are finding deliver all that. But I focus has to be in that context. Now, next big thing is, for example, you this that is WR, PWR, BWRs, all these SMRs. Based on uranium, natural uranium and uranium, but they are all uranium. Now uranium, and today of course worldwide nuclear program is based on uranium. Now if you look at the demand supply situation of uranium, till recently about the percentage can vary, but 50% of the uranium fuel is derived from refined weapons, particularly the the mining and uranium production is today 15-20% short of actual. Now that route is almost higher. People are in the global market, and there are of course plans to set up new mines. Demand supply dynamics. The challenges arises because with zero mismatch, particularly to start new mines, there's a lot of decision period. And during that time, it fluctuates to the other demand supply problem. The demand is likely to go up. IE 300 or today, So, so the question is, I would be at, it's almost writing on the wall. Uranium production will grow, but there will be this mismatch. Superimpose on that geopolitics. You know, geopolitics of oil is really under that. Geopolitics of nuclear is more complex, and that will create that difficulty. The question is, how does it ensure its energy security in light of this? And of course, we're talking about three-stage program from the inception of our program, Dr. Dhawar enunciated a three-stage program, which is aimed at ultimately making use of thorium in large quantities to meet India's energy. We know today India holds the largest endowment of thorium in the world. That is sufficient to meet India's requirement not only of today but also of future, the so-called requirements of Bharat. And also it can probably have some surplus and become just like oil exporting countries, OPEC countries. They have their place in the world because they are energy providers. If we do good of thorium utilization, I think India has an opportunity to be energy provider of the world. Now, this is our potential. Talking about from day one. The challenge is in realizing. It's a difficult challenge. Everybody knows involved in thorium oxide smelting point. There are some acids, metals, uranium, but that all of you have solved. Reprocessing also there are. Most importantly, of course, there are hard products arising out of decay of 232, and so it poses a challenge across the fuel cycle. This is all known. Are we going to wait for somebody else to develop this technology and then adopt problems? This is, to me, really a question. Now, if you look at the rest of the world, they also, same argument applies. The uranium shortage, the issue of uranium shortage can also be solved by adopting closed fuel cycle, which we all do. Most of the world, they have adopted the fuel cycle. They don't like closed fuel cycle. The uranium cycle has plutonium, and plutonium can be chemically separated from uranium. And the material is fed up because of the nuclear weapons connotation. And why the closed field cycle globally has been a more sound argument that, of course, that was because our uranium endowment were quite slow. So we have been always calling spent fuel is not a waste, but spent fuel is a resource. The IAEA convention on fuel management, there is a dual convention. There actually India opposed that convention, didn't explain the work by saying that for us spent fuel is not a waste, but it's a resource. something about it. One way could be to recycle uranium, which might. But the question is, if one can recycle uranium, one thorium has some challenges which I mentioned, but one big hurdle of that barrier to close fuel cycle or not, will you get to work? So once recycle comes center stage, thorium also will become that much more attractive. So I think up to the external developments are main helpers. But beyond that, I don't think they are going to. A lot of development in China, small reactor running as you can see. There are some events which are very much of molten salt reactors. Recognize in thorium slowly receive, and I think time will receive. And, HWR, the main area of our program, fortunately very flexible reactor. HWR, variety of the ours in India have variety of them, including use of thorium for power flattening. I have personally experience when in fact I came to Balramur to get some fuel bundles made of for power flattening. There was again a tussle whether thorium can be used for or not. Everybody says thorium cannot be used for power flattening. Later in your files. But that was one, and now thorium are being used for flattening on the radiation. But the point is, even need to be, and that is the key to success. So when I was in advanced heavy water reactor, the advanced heavy water reactor, actually that came out as a Chernobyl at that time. Because nuclear power program was on the world, it appeared as if everything will be given up. Several programs were scaled down, several countries, India programs, many countries gave up nuclear power programs. So the question, why can't we have a reactor which will not have an impact in public domain? And that was the target requirement for advanced heavy water reactor. And being in India, why not we do this? At least a significant part of energy production coming out of thorium. So that is how the reactor. But that work also gave insights about use of thorium in HWR. Now, the reactor understanding, many people ask me if that we so why it will not HWR or why do you not push through medieval times? A legitimate question. So the issue was at that time we couldn't think of doing this out of enriched uranium. Because to use thorium, you require an additional fissile material, driver fuel. So HWR was entirely on plutonium, thorium. Because that is what we could do indigenously. And that was the same time I was also in PhD. And I told you the question, why are you pushing us where is plutonium? So plutonium was scarce at that time. So as a push PhD, so I decided that I must push PhD. And I think that decision. But then in the process, now come to PhD. To move the three-stage program very quickly. That means we must have sufficient quantities of uranium-233. So that means you must have sufficient thorium at scale, and which you can set up thorium. Look at the original time scale, all that should have happened in the first year. But first years, several comes to cross. PFBR has to go on power, then replicas or repeat of that PFBR, FBR. These reactors, the breeding gain, they breed, but the breeding gain is not high enough. And, let me share an anecdote at this stage. It's a time when we're sitting in late 70s, late 70s, around that time. There was a huge debate. What is the fuel for India? This experience that the ABT reactor, which earlier was expected to be enriched uranium, its Basu counterpart has been, but that enriched uranium was denied. We said we'll do it out of plutonium. Now, ABT fissile concentration in the core is high. You're all metallurgists, so you would know. So you can't work a plutonium uranium combination higher than saturation, 40%, 45% or thereabout. So clearly, oxide was ruled for ABT. So came carbide. PFBR time the question was, if you now mastered the more advanced fuel, carbide, why should you go back to oxide? And I remember, recall, we have come this far in past year, I think major contribution of its pioneer is Paranjpur. So he was championing advanced fuels. And now we are the type of a commercial technology. You can't afford chances. No, has a greater experience, and I had doubling time is very important, but the growth of fast reactors in the early stages would be determined by the production coming from first stage. So you have time. The time will become issue when this field will dry up, then it has to breed itself. So within that time we should develop these advantages. I actually promised him that look, I'll make sure this happens. And so oxide was decided for PBR. And I must tell you that Dr. is no more. But 5-6 years ago, because he was quite old, he telephoned me and asked me, you said advanced fuels will be developed by the time. Where are those fuels? So of course some work was going on, so I still work and the work is going on. Point is, PAPR, which is oxide fuel, is not an end in it. So we mastered sodium technology, sodium pump, all that we know, but we have to move from oxide to metal fuel, simply because that will give you a shorter drilling time that will allow fast reactor capacity to grow, and then you can eradicate thorium on a large scale at which it is required. So you can imagine it's going to take able to do. And now bringing that connotation of the uranium supply in the world, and whether India will be able to manage. So it is in that context I feel that while we have sort of, there is a deep of bringing that capacity, but we are gaining additional capacity in PHWs, which was not envisaged earlier. Talking about 10,000 by 2000, so 10,000, and I'm sure Dr. Baba's time even 10,000 would not have been possible. And it on the level of 1,000 megawatts PHW capacity and build. Now we are talking about 100,000. So it's not that much got sent opportunity to eradicate thorium. We started looking at why not the out of HWR and looking at, let us see if without changing the reactor design to get thorium and to sort of, so that the reactor remains same, no change in the reactor. But fuel, of course, has to be, internal appearance has to be fuel. Inside the thorium enriched uranium, you can burn up, but you can burn it. Burn up can become comparable to total reactors in P. So instead of making 40 tons per year for more tons per megawatt, you can make 5 for your, and it will be for 1 year's requirement. Manufacturing will shrink so much. So there is a cost saving, only in the front end, but there is even larger cost saving because then whatever in the reactor, they will hold a lifetime comfortably. In the process, cost saving on the quantity. In terms of safety, improve because melting point of oxide is higher than uranium oxide. Conductivity of thorium oxide is better than oxide. The margin between operating temperature and melting point is much larger. In fact, this field is under irradiation is complete at Idaho Falls. But this I hear is that towards this because there is a lot of work going on. It is known as accident and field. This is by way of you create metal reaction and so on. But they say existence of thorium itself take you away from it because it runs that much. So they have actually categorized one of the accident tolerance. The core void reactivity is a concern in people. So I have been championing kind of progression towards that continue to do. Can this development be done completely on our own? Perhaps, but you have to overcome two constraints. To qualify this fuel, I want to qualify this fuel in a reasonable time. We did, for example, a bit 50,000 per ton burn-up, but it was done step for 20 days per ton burn-up, then put it to PI, then go. So you know how many years it took, because I know some of you are involved here. We get a reactor, so you can't do that in a power reactor. So you require a reactor platform where accelerated irradiation is done. It doesn't exist in India. So irradiation is civil nuclear that we have in so many countries. Have we done that only for purpose of buying a reactor, or being a partner in development and say, let us do some co-development? That is where the strength of collaboration lies. So, but this is one issue, that you can't do it completely on your own. The non-availability of the irradiation platform. Of course, the enriched uranium. Talking about HALO, now we have enrichment technology, but can we think we have the capacity of it to this level that we have reactors? And the question is, when we are not finding commercially uranium in our own reactors as an attractive proposition, will somebody invest in enrichment on that? So my argument has been, I think we should utilize the capacity of civil nuclear power to cooperate as equal developers, partners in co-development, and be owners of, part owners of. But it looks like we are losing that battle. This field will happen. So anyway, from forward, it is very important that this larger capacity of PHWRs is used in thorium to produce uranium. Then comes the issue of added so much of where is the technology? Again, that should have been now, but in fact, we were committed program, we were committed to development of the reprocessing technology of thorium. And more importantly, recognize that I talked about metal in past year. That also will be there inside. That will be invariably in pyroprocess. Metal fuel recycling cannot be done through processes. A pyroprocess technology which India has anyway developed for metal fuels past year. Now I think the same code, there is small variation, same code of this will compatible with the long-term strategy of metal field. So going forward, while scale is a thing, because one of the big criticisms of performance is we do great technologies, we solve problems not only for ourselves, also the rest of the programs in the country. But the question is whether can we do it at scale. Second thing is to remain on that scale and expand, but at the same time move towards scale, which also is a part of the objective from day one. So to me it is almost inevitable. Why are we not accelerating that program? And to me this seems entirely consistent and actually so so this is the next part of the kind of challenge. But at the same time I must tell you, I don't see which we can always do, you can do a but primary direction, because it is dictated by the energy demand of the country. So I just don't see any other new to play a big role, and there is a timeline attached. I'll take only another 5-10 minutes to close. And that is about, we now have, I think it's a great development. I don't know how many of you know this, but it will now, there is no way industry, there is no way we set up with it. And there is with accountability, you know, there are serious national security. So we have to guard all that, but at the same time rope in, because you know you talk about 100 gigawatt, but cannot find so much of it. So even from availability of finance we require, but also in terms of deployment, in terms of, see the point is you will require nuclear energy only for feeding grids, which of course is the primary purpose. But as it is, you are talking about Bharat small reactor, why do you think they are all talking to DAE? They are talking to DAE because they are all desperate. There is border adjustment mechanism, and so anything exported to countries, if the country is beyond a threshold, it attracts extra tariff. So exports are becoming uncompetitive, and that is where industries which are say steel industry has an ambition of becoming biggest steel manufacturer in the world. And in that, obviously, export is a big element, and this is they want their energy as a captive power, and that's why they're all talking. There are other, you know, artificial intelligence, the data centers, all this will come if we cannot feed them. So they are all huge, big demand for this captive power. And they do differently. Somebody will, I'll take maybe a 50 megawatt unit or attach a set of electrolyzers and produce hydrogen and do business. And if you give power back to purpose, somebody else may say, as I give you an example of high temperature reactor, somebody else, I want that kind of. So even in electricity generation, these requirements will dictate different kinds of these energy, nuclear energy systems. I don't think it's an assumption that we will configure our and supply is impossible. You must have space for other, and then of course we must cooperate. We have to mentor because you were the custodians, biggest custodians of nuclear technology, and I will not hesitate saying biggest custodian in the world. The manpower that we have. I think we should play the role of mentor. Take other people in. Kind of openness must come. Because, and there is demand. Last point that I wish is whenever you do this co-development, for example, a user and a technology provider, development, there will be a lot of pull. The buyer say, but have you got this? Like that you go to the shop and want to buy, you will ask 1,000 questions to satisfy yourself. But then imagine for a moment, the buyer are both a part of the same enterprise of making that product. You plant or you actually create a buyer other than telling that look, you address this question, that question. Those questions are there. To be found. Say, no, we have to find solution to this problem. So I am also finding that solution. That is simple. And you will find itself will accelerate delivery on it. This in normal so-called startups, technology transfer. Always I will develop a technology and transfer to you. Of course, under but technology together, then of course you have to make other person party to intellectual property right that point onward. Before is yours, when you a partnership in development, share the IP also at that time. But the big gain is the technology reaching the market, that process becomes much faster, much faster. And I think many of us in DA recognize that aspect. So we will have a serious process. I will first develop, and I will make a selection on the basis of some criteria. I transfer the technology. I think that will you sign an MOU, technology transfer is done. Hardly happens. Whenever you get technology from others or you give technology, there has to be some people who work together from technology transfer happens in the case. So the same thing is in terms of taking nuclear forward, particularly involving. So I think we need program. Then obviously the side part sitting divide the suspicion and suspicion works, things go at science. I do hope we are technically, technologically commercialization or deployment. And I think all of us, the nuclear energy community, find ourselves best of this opportunity. I am a good man, so I can always say best luck. Thank you very much. I don't know, but I am here for answering any questions. But if that is
very much, sir. Listing talks on thorium generation, hydrogen generation, application, spent fuel management as a resource, needs of the country. To all of us, sir, to remind our responsibilities towards the nuclear security and safeguards of technology in the country, sir. Thank you very much, sir. I now request the dignitaries to Anil Kakodkar, Shri Anurag Kumar and Shri V.V. Mahesh Kumar to come on to the stage, please.
मैं महेश कुमार सर बात करता हूँ कि वो हमारे मुख्य अतिथि का फ्लावर पोट देके अभिवादन करेंगे। मैं निवेदन करता हूँ श्री अनुराग को जो मुख्य अतिथि का सॉल उड़ाकर स्वागत करेंगे। मैं निवेदन करता हूं मुख्य कार्यपालक महोदय डॉक्टर कोमल कपूर से कि वो मुख्य अतिथि का स्मृति चिन्ह भेंट करके अभिनंदन करेंगे। श्री ए.पी. राजू को
Thank you, Judge. Very good evening to all of you. Honorable Chief Guest, Chairman and distinguished guests, Dr. Sir, CNFC, Chairman CNFC, Sri Anurag Kumar, Sri V. Mahesh Kumar, President, NFC, and Pratyush Kumar Chakravarti, our Director of Finance, ECIL, CDS, and Indian friends. Yes, Hyderabad. So I expect Dr. Anil Kakodkar sir for accepting our invitation with a very short notice. And your talk on future prospects of nuclear energy in India was insightful, thought-provoking, and inspiring, sir. It serves as a compass for all the scientists for future work. And we thank Dr. Dheeraj Pandey, sir, Director AMD, and CWD ECL, Dr. A.K. Sharma sir for his support during this INS event. And I have to mention a special thanks to Dr. Komal Kapoor sir for his continuous support and mentoring us throughout this event. And also a special thanks to entire NFS team for the excellent arrangements and warm hospitality. We also express our sincere thanks to NFC Officers Association for joining hands with INS Hyderabad in organizing this event and making it a grand success. We thank Sri Anurag Kumar sir, Chairman INS Hyderabad, and our INS Secretary Hyderabad, Sri Balachandra sir, and also the entire organizing team, the volunteers, technical staff, and for smooth conduct of this program. We give special thanks to the madam, Mrs. Sekhar Basu madam. With a very short notice, we could able to start last night, and we have sent a message. Madam has immediately replied at 9. And she would like to join to some short to join, but best wishes to what we have a short interaction and myself. Very happy organizing this event. And we hereby note that around 250 participants have participated here, and also more than 200 people have joined online. So making it a success, a true New Year celebration. And thank you all for your enthusiastic support. We remember with great respect the legacy of Dr. Sekhar Basu, in whose honor this lecture is organized. His contributions continue to inspire all of us. This I conclude the program and request all of you to please rise for the national anthem.